Hello and welcome back to the lab. Rock and roll edition. No, just kidding. I bought this Squire Telly about 25 years ago. I don't really play it anymore, but what I do is use my amplifier for testing in the lab. Um, so I thought I would make some measurements on my guitar amp using various pieces of HP test equipment that I've been collecting over the past few years. If that sounds like something you'd be interested, stick around and let's go. Also, I wanted to let you know that I have many more interesting projects in the pipeline that I haven't really gotten a chance to get started on yet because of some other interests I have, and I'll talk a little bit more about that at the end of this video. So stay tuned for that. All right, so for my first test, I wanted to measure the output power of this amplifier. Um, it's a model number Frontman 15R. The R stands for reverb, of course, so I have the reverb turned all the way down. And I'm assuming that the 15 stands for 15 watts of power. I don't know that to be a fact, but I'm assuming that that's why they would call it the 15R. I don't really know. I'm a little skeptical if this thing can actually put out 15 watts, but it's possible. But we're about to measure that and find out. So the first thing I wanted to do was to determine what sort of a signal level would be appropriate for the input of the guitar amp, because I don't really know what kind of signal amplitudes I should be driving this amp with. So I took my guitar, the output of my guitar, and connected it directly to the 3455 in AC volts mode. And I'll just strum a chord. We'll do an A major bar chord, big old power chord here, and we'll see what kind of voltage we get directly out of the guitar. Looks like something around maybe 50 millivolts RMS of power coming out of the guitar directly. All right, so that we'll use 50 millivolts as our signal level um, for our test setup for measuring the power on the amplifier. All right, so let's take a look at our actual test setup in making this measurement. Now, I spent so much time over the past month or two working on these tube-based instruments to get them up and running. I decided to go ahead and use them to make this measurement. So we have our 200 CD as our signal source, our 200 CD oscillator. Um, the output of the 200 CD goes into the input of the 350D 600 ohm step attenuator because the output of the 200 CD is quite high and we only need 50 millivolts of output. So we're going to use the step attenuator. I have it set to 30 decibels, 30 dB. So it's going to drop the output of the 200 CD down by 30 dB before going into the rest of the test setup. From the output of the 350D attenuator, we have a 600 ohm termination back here, which you probably can't see. Also, we have a 100 kilo ohm precision series resistor coming off of that output to more closely simulate the output impedance of an actual electric guitar, like the Telecaster that I was using. So we're just going to assume that the output impedance of the Telecaster is like 100 kilo ohms. I don't really know what it is, but we can assume that it's high. So I'm going to use this 100 kilo ohm resistor in series to give this source a 100K ohm output impedance. From the output of the 100K resistor, we go into the 400L vacuum tube voltmeter, and that will measure our input signal level, and we will set the 200 CD for 50 millivolts, like what we measured coming out of the guitar. So we'll look for 50 millivolts on this 400L vacuum tube voltmeter. The output goes, of course, to the input of our guitar amp over here. The output of the guitar amp goes into the 8 ohm dummy load that I put together, I guess it was last week or 2 weeks ago. and through the 1/4" phone plug here. We're also measuring across that 8 ohm resistor with the dual banana plug, which goes over here to my 400H vacuum tube voltmeter, which will measure our output signal level. And we're also going from the BNC connector to the input of my scope. So we can take a look at the waveform to check for clipping and so on and so forth. So what we're going to do to make the measurement is adjust the output of the 200 CD until we get 50 millivolts RMS on this vacuum tube voltmeter. That's what we measured coming out of the guitar. So that's what we'll set this for. So I'm slowly turning up the 200 CD until I get a 50 millivolt RMS voltage level, which would be right about there, coming out of the 100K series resistor. Now that 50 millivolts is fed into the input of the amp. And now what we're going to do is turn up the gain control on the amplifier until, while watching the scope, until we get some clipping. So we have maximum gain before clipping, before distortion on the amplifier. And that will be right about there. You can see that for some reason it breaks into oscillation if we go higher than that. I'm not sure why that is, but if I reduce that level until we have just below where it starts to clip, and then we'll come back and we'll measure the output signal level using the 400H voltmeter. And if I take that reading, it looks like it's well, it looks like it's just about 11.1 volts RMS. Now from the input reading, well, our input has changed a little bit. Let's turn that back up to 50 millivolts. From taking the input reading and the output reading, we can calculate our voltage gain and our power output. So let's do that now. Okay, I had to go back again and more carefully take a look at the input levels and the output levels. So I've checked the input level and it is still 50 millivolts. And the output level is now, looks like 11.20 volts on the output. So let's calculate the power output, and we can calculate the voltage gain from those values. And when we make those calculations, power, V squared over R, 11.20 squared divided by 8 ohms, 15.6 watts. So it is indeed a 15-watt amplifier. I'm actually kind of surprised. I'm surprised it worked out that way. Voltage gain equals 11.20 volts divided by the input, which was 50 millivolts, and that's a voltage gain of 224. When we calculate the decibels, 20 log of 224 is 47 dB. So this amplifier has 47 dB of gain. Pretty good, pretty good. Now, I didn't measure distortion. I didn't measure frequency response, and there's all kinds of other variables that I haven't really measured. But I think that will do it for this video. Now, I do have many other projects in the pipeline, but most of them I haven't started yet. I have a full-time job, so I like to do my videos on the weekends. But lately, my weekends have been pretty busy with another activity that I enjoy. Each year, in the end of April, thousands of cyclists gather in Houston, Texas for the annual MS 150 ride. It's a 180-mile, 2-day charity cycling event to support the National MS Society. This will be my 12th year participating in this event. It's a very challenging ride for me, so I train every weekend from the end of November through the end of April. But when I cross that finish line and strike that now famous victory pose, it makes it all worth it. Thanks so much for your support as I train for this ride. So thanks very much for watching, And thanks for giving me the opportunity to share my hobby with you. Please like and subscribe, and stay tuned for more interesting videos with vintage HP test equipment and other interesting stuff. Thanks again.